Hello, I'm Kenny Grip. I'm the MySQL product manager, focusing on high availability replication InnoDB. And today I'll be talking about MySQL database architectures, high availability, and some of the solutions that we have in MySQL for this. First off, we have the safe harbor statement. Please have a look at this. I would like to start a little bit with what MySQL has been around for like 25 years, and there's a lot of things that MySQL had for a while, which is called MySQL Replication, and this became very famous. A lot of people are using MySQL Replication to setting up their own replication topology, and it's very flexible. It's basically a piece of technology that has been developed, and that's one of the main reasons how MySQL actually got used a lot, because of this flexibility of logical replication. And MySQL always has given those technical pieces to users, and then it was mostly up to users to figure out a certain database architecture that fits their needs. And the unfortunate thing here is that for our users trying to kind of deploy a MySQL architectures, that's a lot of work, a lot of knowledge that they have to learn, a lot of customization, and basically every environment kind of turns out to be kind of a custom database architecture. So you have a lot of DBAs that are kind of working full-time, working on setting up these architectures, automating these architectures, and they often have to rely on other software, either proprietary or open source, to deploy an architecture like that or to provide failover functionality. Even restoring backups, configuring replicas, user management, all of these things have to be done manually. So it's quite a lot of work. So with that, I would like to introduce today a little bit about, okay, this is legacy. This is kind of what people were doing in the past. And this is kind of our focus now. Since 2016, we introduced a new piece of software called MySQL InnoDB Cluster. And this is more like a solution for us. And this is basically a set of technologies that MySQL developed and Oracle internally as one team to kind of provide the user an integrated and easy to configure database architecture that gives you some guarantees. So 2016, we have these three components here. So four components actually. So we have InnoDB Cluster, and InnoDB Cluster is built on MySQL Group Replication, which is a set of MySQL servers communicating with each other, replicating with each other, which provides this automatic membership, network partition handling. It guarantees consistency across all members, and there is no data loss in the event of a failure happening. Then we have the MySQL router, which provides access from the application to the database architecture, regardless of which member it is. It will redirect, proxy it to the member that is intended. And then for ease of use, to configure and manage this type of setup, we have the MySQL shell, which is a command line client, which besides the regular known MySQL client, is just a more powerful client that supports programming, customization, and does all this automation. And this is kind of one of the areas that I will talk about. I'll give a little demo later in the presentation as well. And then another important thing that we introduced is InnoDB Clone. So InnoDB is MySQL's main storage engine where all data is stored. And Clone provides the ability for a member to fetch the data through a MySQL connection from another member and provision itself. So there is no need any longer to take a backup, restore a backup, configure replication. So all these steps where the user had to manually or automate themselves, it's all built into MySQL InnoDB Cluster and Group Replication. And this has become quite popular, and I'll delve into the details of each of these. But in 2020, earlier this year, beginning of the year, we introduced another solution, which is it's very similar to MySQL InnoDB Cluster, as you can see. So the router and shell aspect remains the same, but this is using MySQL asynchronous replication. So InnoDB Cluster, when I go to the previous slide, is based on group replication. InnoDB Replica Set is focused on asynchronous replication. So when you think about MySQL replication, you might think about regular asynchronous replication. And that's what most people, at least in the past, have been using. So this is kind of the presentation of today. I'll show you a little bit what each of these components are, and then also show a little bit of, okay, what solution would fit your business needs, kind of depending on the requirements that there are, and I'll show you some example architectures based on that. So let's start with InnoDB Cluster. And InnoDB Cluster is those four components as I mentioned. So it does provide high availability, some scalability built in, and it's just an integrated end-to-end solution, very easy to use. And basically, you can set up an architecture like this in about 10 commands, and it will do everything from provisioning the host to setting up everything, creating the accounts, everything basically. So what is the goal of InnoDB Cluster? So it's one product, and this is important. We want to make sure that we can give one product to our users, to our customers, that all of these components, they're developed, they're tested together as an entire solution, and everything is integrated. And it makes it easy to use. That's kind of the result out of it, but also that we can guarantee certain things. We can say this will work. With replication, you kind of can go because of legacy replication, it's just a matter of configuring replication, and you could customize this so much that there's a lot of pitfall limitations that you're creating. And with this solution, we kind of guarantee this works, this is easy to use, and because we do all this testing, yeah, we can kind of guarantee that to our users. And then this easy to use and orchestration, and I'll show you a little bit later on how this works. So let's delve a little bit into the group replication aspect, which is the kind of the core part. So first of all, we have the MySQL server. We have multiple MySQL servers. In this example, we have 3 MySQL servers, each running InnoDB storage engine to store all the data. And group replication is the component on top of that that provides all this high availability, this failover and whatnot. So some of the properties are also that you can have a multi-primary, meaning that you can write to all members at the same time. And there is a guaranteed conflict detection resolution, so guaranteed that your data remains consistent across the whole cluster. It's also built in data loss prevention, so it's built on a Paxos-based protocol. And we can guarantee that when a member fails, that there is not going to be any data loss at all. Adding and removing members is very easy. It's just a matter of starting a MySQL server, and it will automatically try to connect and join the group. It will recover, get the incremental changes or reprovision if needed, and it will handle all this automatically. In the event of any network partitions, any failures, all this is handled by the group itself. There is no external monitoring node. MySQL shell and router don't do anything. They just merely observe or send management tasks to configure things. They don't make any decisions. So group replication by itself makes all the decisions. So basically, it's an implementation of replicated database state machine. So every write in the whole group, so on this group replication, let's say this 3-member group, all writes are ordered across the whole group. And it's using the XCOM protocol, which is internally developed by MySQL, which is this Paxos-based implementation, which guarantees that all these writes are ordered. We have the option in group replication to configure the consistency levels. So with traditional asynchronous replication, when you read on a secondary member, the secondary member can be a little bit out of date, and you might do a select and you might see some older data than if you would do the select on the primary instance. With group replication, this is the default behavior as well, where the data could be a couple of milliseconds out of date, but you can configure on a session basis, on a statement basis, on a global basis, whether or not if you want any certain consistency levels stronger than that. So you can say that for this session, I want every read to make sure that it reads the latest view of the data. And there's several options there as well on how to achieve that, because there's an impact, because communication has to happen with the other members, and you can decide whether or not you want this consistency to be happening at the write level, so basically adding the overhead during writes or adding the overhead when a read happens. So it kind of depends on your use case, and how many writes or how many reads you do, your network, and so on. The beauty of this is that this is not just another type of implementation of replication. It's still using MySQL replication framework that asynchronous replication is actually using. So it's still relying on binary logs, relay logs, the global transaction IDs, GTIDs, which is something often used to make management of replication easier. It's fully using this framework by design. So it's not just something else built on top of it, which is again customized. So you can easily mix and match group replication with replication. There is no specific requirement there or anything else. So it's been GA since MySQL 5.7 back in 2016, and it supports all of our platforms, so Linux, Windows, Solaris, OS X, and FreeBSD. Group replication, by itself, so we're talking about InnoDB Cluster, that's how I started, but group replication can be deployed by itself. You do not have to use InnoDB Cluster. So for advanced users, we have customers that are advanced that do not wish this integration. They want to do their own automation, their own topologies. You can just deploy group replication yourself. So there is no requirement for this shell and router. It works on its own. But we suggest to all our users, of course, try InnoDB Cluster, get this integration. It helps a lot. But yeah, we have some few users that only use group replication. So why would we want to use this? So the first of all is RPO 0. So in the event of the primary failing, one of the primaries failing, we can guarantee no data loss. There's also a split brain prevention. So we're doing a quorum calculation when a network partition happens, anything changes. And then we decide which network partitions remains primary, which can still continue, and which ones needs to block themselves. The impact of this is, of course, that we cannot guarantee in all situations that the system will remain available for writes. In the event of having a two-member group, which we do not recommend, if there's a network partition between those two, when you calculate quorum, each network partition has 50% of the total available members, and that is not enough. You need more than 50%, so a network partition needs more than 50% to be able to continue. So in that case, writes will not be allowed anywhere until the network partition is resolved. So this is, of course, the impact that when you want to guarantee consistency, that this could, in some rare scenarios, hurt availability. Automatic failover is built in, so you can manually move the primary role. So the default method of operation of group replication is single primary mode, meaning that there's one primary, multiple secondaries. The secondaries are available for reads. The primary does reads and writes anything. You can manually move the primary role, so it's just a call you do and say, okay, set this, make this one the primary. That works. But also during this network partitioning, the primary will be moved as needed. Read scale out is an important one. So one important aspect to not confuse, this is a means of replicating data. This is not a cluster that provides you scale out possibilities. It's not like there's some built-in sharding or splitting of data across members. Each member has the full data set available, and it's basically for high availability read scale out that group replication is used. So you can add and remove members as you need. There's this concept which is new because group replication does all this automatic handling. It also is aware, each member is aware of the state of the other members. So if one member is lagging behind, it can actually throttle some of the workload, so it makes sure that other members do not fall further and further behind, which can reduce or eliminate replication lag, which is often seen with asynchronous replication. So this is built in, right? With classic asynchronous replication, you would have some monitoring that monitors replication lag, takes action upon any lag that you think is too much, does certain things, which is a lot more customization, again, that is needed. And with group replication, this is not longer needed. And as mentioned before, you can configure these consistency levels, which is another great thing that a regular traditional replication does not have built in. So group replication has this built in. So you can write to multiple members at the same time, and the writes are ordered within the group. So you can write to multiple members at the same time, but XCOM, this communication layer built on Paxos algorithm, will guarantee this consistency. The write performance is actually quite good, and it implements a certain kind of optimistic locking. And what happens is that when we do a transaction, or when a server is doing a specific transaction, the transaction remains local. So the transaction is using some, maybe have some row locks, it's adding some data, deleting some data, and all these locks remain local. It's only when a transaction is committed that there's a single round trip to the other members to replicate it, and then also to establish order and confirm that they have accepted the transactions. So the overhead during a transaction is zero. It's only at commit that there's one round trip. So the impact on there is that when you write to multiple members at the same time, that it is possible that transactions get rolled back because they conflict. When the transaction is committed, the other members on one member, the other member has to validate if there's any other conflicting transactions that might need to be rolled back. So there is a chance in some workloads where you update the same row often on multiple members at the same time, that you will have more kind of rollbacks happening. But again, this only happens when you have it in multi-primary mode, multiple members, write to multiple members at the same time. So this was group replication, and now let's go a little bit into router very briefly. And router is a application. It's a very lightweight, and it provides just an interface for the application to connect to. And router takes care of figuring out where is the primary at this moment, where is a secondary at this moment. And it does like transparent routing. It does some kind of load balancing. It handles the failover if needed. And it's very lightweight. It doesn't need hardly any configuration. It's stateless by design. So it does not make any decisions. It just follows the group. It monitors the health of the group. The group can also send membership changes to the routers. So with MySQL, we have a MySQL protocol called the X protocol, and we can send notifications through there. So when a member is added into group replication, so a fourth member, for example, MySQL router, all the MySQL routers will get a notification saying that, hey, the membership has changed, and they will learn about these things. Similar when new primaries happen, members are removed, and so on. The beauty of this router is that it's aware of group replication. It's aware of InnoDB Cluster, and it's also aware of InnoDB Replica Set, which I'll touch upon next, is that it knows this architecture, which was configured using shell. So basically what happens is if we deploy an architecture with InnoDB Cluster, InnoDB Replica Set, with shell, it creates some metadata, and router just follows this metadata, knows where all these members are, based on this metadata as well. So at this moment, router is a kind of opens up two TCP ports, one for primary traffic and one for non-primary traffic, which is very common in MySQL, is to say, okay, my reads go to a different port. So you configure your application to say that this port is for reads, that other port is for primary traffic, reads and writes that are primary. And then the last component of InnoDB Cluster is shell. And this is a very simple, intuitive tool, but it is very powerful underneath. And the default mode when we launch MySQL Shell is JavaScript. So you can write JavaScript, you can write extensions in JavaScript and Python. So it has JavaScript, Python, and SQL interface. So you can write any code in Python, JavaScript, include that. And this is also how we work and interact with configuring it. We either use JavaScript or Python mode for this. Shell also implements and supports the X protocol, which has a document store. So if you want to do NoSQL, some kind of document store, MySQL has this as well. And it supports this model as well as the traditional relational model as well. So here's an example on how easy to use this is. So if we want to configure in MySQL InnoDB Cluster, we connect and start MySQL shell. We connect to a server, which is the first command, and then we say, okay, cluster, let's create a cluster object and say DBA create cluster with the name cluster. Simple as that. It creates a cluster, and admin at MySQL 1 is the user with the host name. So MySQL 1 will become a single member group. We can then configure a second instance, in this case MySQL 2, and add that instance to the group. And it's just a matter of cluster add instance, admin at MySQL 2, authenticate, and then shell will take care of the rest, group replication will take off the rest, and you'll end up with a two-member group. Same you can do for a third member as well. For router, it's as simple as bootstrapping it. And bootstrapping is basically you instruct to generate the configuration by saying connect to one of the members. So you just give it the host name of one of the members of the group, and then get your metadata from the database and configure yourself. And then you start router, and router will be up and running. There are some configurations you can do, of course, in router itself, but that's out of the scope of this presentation. So as soon as that I added 3 members, I can just do cluster status in this MySQL shell. So I do cluster status, and you can see that, okay, we have the primary is MySQL 1, we have a topology with MySQL 1, which is in read-write mode, MySQL 2 in read-only, and MySQL 3 in read-only as well. So this is how you can get the status. You can do a lot more cluster operations like moving primaries, adding, removing members. All happens through this kind of JavaScript interface or Python. So this is not some new piece of software. This has been developed since 2014, which when the first release came out, and it's been GA since 2016. And ever since 2016, there's more and more features that were added. So we added more encryption features, the node provisioning was added as well. We added more support for large transactions. We improved network partition handling, and we're continuing to improve features, adding features and improve group application basically at nearly every release of MySQL. So what we've seen since we released this in 2016 and made it production ready is that many of our customers really love it, because nowadays DBAs have to manage multiple types of database systems. They don't longer only do MySQL. So the less time they have to spend on one database to manage, the better. It also makes it easier to use, so you need less experienced DBAs, basically. You don't need to be an expert just to get a database architecture set up. It really doesn't need to be. And it's this integration with router and the ease of use with shell which provides this. Of course, this group replication brings this no data loss, automatic failover, the consistency. All this is very important, of course. But this ease of use is really what appeals as well. And that's why we decided to also release InnoDB Replica Set, which is a similar architecture here, which is basically the same router, the same shell, but using traditional replication. What does it provide? It actually provides quite a lot less than group replication, but we have still a lot of users that want to use asynchronous replication because of their business requirements. Or we have customers that have a very bad network where there's a lot of packet loss or very high latency, and group replication wants a stable network, of course. With asynchronous replication, all this is becoming less important. So what does it provide? It's basically shell and router configure and route the traffic to replication. And it's regular traditional asynchronous replication with manual switchover and manual failover. It provides read scale out. It does not guarantee that there is no data loss because replication is asynchronous. So if we compare this to the past, right? So we have still a lot of these legacy users that are deploying MySQL replication architectures themselves, and that's the target, right? That's what we want to improve. Is that okay? In the past, you had to restore a backup. Now, InnoDB clone will take care of provisioning new members, so that saves a lot of time. InnoDB clone is also far faster than anything else. Even making a MySQL enterprise backup and then restoring that, InnoDB clone is a lot faster. In the past, you had to configure users, configure replication. Shell does everything for you now. It configures replications, the encryption, everything. Adding and removing servers in the application or in a router or any proxy was manual as well. Now this is all integrated. Router learns about new members. Because of this metadata that Shell maintains, router just follows. It's stateless, just follows these topology changes. You don't need to rely on any external tools. A lot of these tools have some external monitoring hosts. You don't have to have this. It makes it a lot easier to deploy. And this is a very easy to use switchover failover tool as well, which was kind of manual as well in the past. In the past, you had to manually check if you had a couple of replicas. So MySQL InnoDB Replica Set with 4 members. One is primary, the other ones are kind of replicas. The monitoring had to be manual, had to log in everywhere. So with Shell, you can just check the status. It will check the status of everything. Is there any replication lag? Are they healthy or not? And of course, simplicity. It's a standardized setup. It's supported and developed by Oracle. QA is being done on this whole architecture, and it's no longer a customized setup. It's a standard solution that we provide. So there are some requirements here. So we rely on MySQL 8, and MySQL 8 has been generally available for a while already. It's like 2 years. And it relies on a lot of features because MySQL 8 really did a really great job on adding features to manage your database remotely. You can change the MySQL configuration over a MySQL connection. So this shell you can run on your laptop and it will do everything. It will configure, restart the server, everything. You don't have to kind of manage my.cnf files. You don't have to run shell on the host on the database server itself. Everything happens over a secure MySQL connections. So it requires MySQL 8 replica set. Group replication works on 5.7, but we really recommend to use MySQL 8 for all these administrative features that make it easier, but also because of extra features that are MySQL 8 only, of course. We do not support multi-primary mode with Replica Set because there is asynchronous replication and there is no built-in conflict detection and resolution. So as long as we cannot guarantee that, we cannot make this a standard solution. And all the secondary members also replicate from the primary as well. So now it's time for a little demo. So I'm going to demonstrate here how setting up an InnoDB replica set works using traditional asynchronous replication. So when we start MySQL shell, you can see it starts in JavaScript mode. And now we're connecting to a host. And I have 3 MySQL servers on 3 different ports on local hosts. So we start on 3301. And we say, OK, let's create a replica set, create replica set. And then we give it the name called replica set. That's it. We created our replica set. Of course, for now, this is a single member replica set. So nothing was configured yet. No provisioning had to be done. It's just using that server as the one that has the data that we need. And that's it. So if I check the status, it's all instances available, 1 member. Now we want to add another instance. So in this case, we want to add 3302. And the question that it asks, because this is a new system, it has no data at all, it asking, okay, how do you want to provision the system? Do you want to just configure incremental replication, so replication and replicate all the changes, so the binary log in MySQL, or do you want to clone the system, provision it, take a snapshot from the 3301 host and deploy it on 3302 that we're adding? So you can see that it's doing clone here. And shell is not doing anything. Clone happens between the 2 database servers itself. Shell just initiates the action. So as soon as that is done, it's added to the replica set. So when we check the status, we can see we have 2 members now, and the secondary is in read-only, primary is in read-write, and then the replication status is, okay, everything's good. It's waiting on transactions. Same thing when we add a 3rd member. Clone is happening. The system is restarting, preparing with the latest data. And then when we check the status, we have 3 members, 2 secondaries, 1 primary. So let's do some things here. So one of the tests that we can do is we can change the primary. So we can say, okay, I want to do some maintenance on 3301. Let's make 3302 the primary, which I did through set primary instance 3302. If I check the status now, replication is reconfigured, and all the other members are replicating from 3302. 3302 is in read-write, the other members are in read-only. So we guarantee that there's no split brain. This is a planned failover. Everything worked as intended. So we can guarantee that everything is fine. Now let's create a failure. Let's stop 3302. So Shell has this kind of sandbox functionality, so I can quickly spin up some MySQL servers to test, and this is what I'm doing. So I'm saying stop sandbox instance, which is just a stop my test instance. So I killed the primary, basically. It stopped. So if I now check the status, so first of all, I need to create a new replica set object from 3301. And we can see that when we check the status is that 3302 is unreachable, can't connect to it. But you can see that 3303 has an error. Replication is broken. Why? Because it cannot connect, so replication is broken. 3301 has the same problem, of course. So how do we resolve this? Well, we can do a failover, and this is forcing a primary instance. So let's say 3302 is gone. I want to make sure that 3301 is active. I want to do this. 3302 could still be network partitioned and active somewhere else, and it's happily accepting writes. So there's no split brain prevention in Replica Set. Group replication, InnoDB Cluster does have this built in, of course, and would do this all automatically. But Replica Set, yeah, it's manual here. And you can see that we made 3301 primary. We forced it to become primary. So when we check the status, we can see that we're partially available. We have an invalidated host, which is the old 3302. And we have 3301, which is read-write online. And 3303 is now replicating from 3301 because it's now the new primary. Now, when we recover this, so we do start the sandbox. So again, this is like this internal testing tool. We start 3302, it comes back, it crashed, or disk was gone, it rebooted, it starts up. When we check the status, it will show, okay, this instance was invalidated and I can access it again, but it's in read-write as well, because it was the old primary. So it is gonna accept writes. So the way to solve this is just you do a rejoin instance. Now, the beauty of all this with Shell is that you can write your own automation on top of this. So you don't longer have to manage or automate the actual failover process. You just have to automate any decision process if you want to further automate this. And you just invoke these commands. We have a CLI as well to command line, single one-liners you can write. You can write Python, JavaScript, and invoke this. That works all well. So we rejoined the server, and there was no kind of split brain. There were no transactions that didn't make it to the other members. So with asynchronous replication, we're talking about milliseconds of data loss potentially, that because of the asynchronousness of it, usually. So no issues here in this case, so everything's fine. Next thing that we'll do is, so everything's working fine, is we're going to deploy router and show how easy it is to deploy router. So I do MySQL router, I say which user to connect to which host I want to. So user MySQL router is the operating system user MySQL router, and I'm bootstrapping it with the user root at localhost. I enter the password, and then it will figure out using the metadata, okay, I have, I know where all the other members are, I'm writing it, storing it, and then generating a config file. So if I now check the log of MySQL router. And then I'm starting MySQL router. You can see that it has a certain topology here. So 1, 2, 3, one in read-only, the other one's in 2 in read-only, 1 in read-write. That if I change the topology, let me pause this, it changed automatically. It figured out, oh, the metadata changed, I need to change as well. So it figures all this out. So I can change topology and immediately all the routers will happily adapt to it as well. So this was the demo. Just to compare cluster with replica set, so create cluster, create replica set. So it's almost the same command. Configuring, configure instance, configure replica set instance. Adding an instance is just add instance. So there's hardly any difference between how to use InnoDB cluster and replica set from a user point of view. Router bootstrap is exactly the same. So just to show you, there are, of course, the force primary is something that is only available in replica set, for example. Set primary works on both instances in cluster and replica set. So now to finish is like what does the business need, right? What do you need? And what we have is that we have RTO and RPO. So how fast should I recover from a specific failure? So RTO, this is the recovery time objective, and RPO, how much data can I lose from a specific failure? There are different types of failures. We have single server failures. We have a network partition. So that's kind of high availability, takes care of that. We have disaster recovery. So it's a full region or a network that fails. Is disaster recovery. And then we have the kind of a human error. It's like the Bobby tables, little Bobby tables, where there's like an SQL injection, data gets deleted or by accident. So how much data can we lose? How fast we need to fail over in each of these cases? So which solutions is good for my business? So if we think about single region solutions first, if the RTO, recovery time, is hours and the RPO is minutes, then a single MySQL server with a MySQL Enterprise backup on a remote host, with syncing up the change stream, the binary logs on a regular basis, can give you this quite easily, of course. So that's not all too special. If your recovery time in the event of the MySQL server failing is still hours, but you want less data loss, MySQL Enterprise backup for the full backups, and then the point-in-time recovery is dealt with remote binary log pulling. So there's a method to actually continuously pull binary logs to a server, to another host, and that gives you less than a second of data loss in most cases. So that's also a very simple architecture. Now, if you need to recover or fail over in minutes, and your data loss is less than a second, then InnoDB Replica Set is a good solution. So this is what I've described and did the demo on today. If, of course, you want a recovery time to be seconds, and you don't want any data loss at all, then MySQL InnoDB Cluster is your solution. Now, this is single region, and this only takes care of like high availability or like a failover when a single server fails or a single failure happens. But when we talk multi-region, things get a little bit more complex, of course. So let's forget about the RTO and RPO requirements on a single server, but we're talking about region failures now. How fast do we need to recover from a region failure? Which can be or should be different in many cases even than a failure on a specific server. So RTO minutes and RPO seconds. What you can do is that with some data loss allowed, this InnoDB cluster on a single data center and then a single replica on another area, you can actually fail over quite fast. Now, another one is that if you need to fail over in seconds and you don't want any data loss at all, then you need to configure InnoDB cluster across multiple regions. So each gray bar here is a region. So we have group application configured in 2 regions, 2 members in one in the other, and you need to set the consistency level to after. Then you can guarantee no data loss when any region fails. Or you deploy members across 3 regions, and then we can guarantee no data loss as well. With Paxos, it's the majority that matters. So that's why we need to have this consistency level after, because majority is reached within a single region. So this helps no data loss when a region. And then there are some more requirements that you might have. InnoDB cluster, like fully consistent reads, multi-primary. Here's a case where each member is primary, nothing out of the ordinary. And this is kind of the summary on each of the solutions that I mentioned. So depending on your requirement here, the solution changes, and for single region and multi-region.